Okay, so exercise 12L, question 1, application problem, a fairly straightforward one, this one. So this one's on page 437 and the rest are on page 438. So question 1A, or question 1, says the position vector of ship S is 30 kilometers north and 60 kilometers east, and the position vector of buoy B is 20 kilometers north and 45 kilometers east. And then you've got a couple of questions there. So as usual with application problems or modeling problems, the first thing to do is to model it somehow, in this case by diagram. And so what we'll do is we'll try and locate that ship and that buoy based upon the information we've got. Now, it says they're position vectors, so we need to take an origin. Now, the origin might be, distance away from an island or from a buoy or from a third ship. We don't know. We're not told what it is. We're just told it's position vector. So we'll start off with a little spot here, which we'll call the origin. And we have here a position vector for the ship, which I'm just going to call S vector in the end, 30 kilometers north. So let's call this 30 kilometers north. Sorry if I'm keeping you up. Okay, so that's a 30 kilometer magnitude, isn't it? And 60 kilometers east. Just having a look at the other problem, you see, and I'm just trying to make sure that I give myself enough scale. So 60 kilometers east. Was that about right? A bit longer, maybe? Okay, so 60 kilometers east. And that means that the the vector itself is going to be something like that, which I'm just going to label as a little lowercase s vector. And I'll say the point, remember that the point is different from the vector itself, so the point is s here. Okay, so 30 kilometers north, 60 kilometers east. I've labeled the vector as s vector, and I've labeled the endpoint as s. Any questions on that? Cool. Just in a different color, I'll do the next one, which is the position vector of buoy B. So from that origin, from that blue point again, I'm going to go 20 kilometers north. So what's that? That's about, so it's 2/3 of the way up, isn't it? So I'll just do little red dots there. They're supposed to be on top of each other, but I'm just putting them next to them. That's about there, isn't it, I suppose? So that's 20 kilometers. And then 45 kilometers east. So, oh gosh. I might just fudge it a bit and say it's about there or something. That looks like it's a bit too long, but I hope that's okay. 45 kilometers is the magnitude of the easterly direction there. And so therefore, the position vector of the buoy is going to be something like that. What do you reckon? Is that okay? That's all right, isn't it? Okay, so that's the modeling of the information we're given. And then the questions are, what is the position of the ship relative to the buoy and the exact distance from the ship to the buoy? Okay, so let's get on to that. So I'll do question A up on slide 2 there. So the position vector, so I'm going to call the position vector P vector. Sorry, not position vector, the vector P vector for position. I'm going to do it in blue here. And if you think about it, it says that we need to work out the position of the ship relative to the buoy, which I haven't labeled as B here, but I'll do that now. Relative to the buoy. So because it's a relative position, then we really just need to work out the vector from the buoy to the ship. So in other words, we're looking at the vector here. So I'm going to do that in blue so you can see that. Please stop and ask me questions if you're not too sure what's going on. Oops, I'll try that again with my lines tool instead, just so I can pretend I'm professionally putting straight lines in, like that. Okay, which I'm going to label P vector. It's not a position vector, but it's a vector of the position to blah, blah, blah. And I should have labeled this B vector. Okay, so does that kind of make sense how I've set that up now? So that blue vector is the position of the ship relative to the buoy. Okay. So looking at the diagram, we would work out that the buoy vector plus that relative position vector, I wish I hadn't called it P for position, but this vector here, the red vector and the blue vector, would add up to the black vector, wouldn't it? Just using our top and tail sum of vectors. The sum of this one plus this one must equal the sum of that one, must equal that one. So rather than muck about with it too much, my inclination is to simply say that. So I'll say B vector plus P vector must equal S vector. Okay? So then I can say P vector is equal to S vector minus B vector, because we have already established in previous understandings that we can basically add a negative vector to both sides like that. That is consistent. Now we can substitute in the ship vector, which is 60, 30. Make sure we get those numbers around the right way, remembering that it's an XY vector, and so we would need to put in the 60 kilometers east first, and then 30 kilometers north as the second one. What happens if it was 60 kilometers west? Someone muttered it. Was that you, Ollie? What did you say? It'd be negative 60, yeah. So using our usual understanding of north, south, east, west there. But it's all positive, so it's all good. So minus, and then we've got 45 east, and we've got 20 north, so that's what we're subtracting. And that gives us, well, we'll just do it in one step, I think. 60 take away 45 is 15. And 30 take away 20, oops, I was going to write 20 then, is 10. So that's our position vector. So it says, what is the position of the ship relative to the buoy? That position vector, 15, 10, perfectly and entirely describes the position of the ship relative to the buoy. If you want to, you could then conclude 10 kilometers north and 15 kilometers east. But it is perfectly acceptable to leave it in vector form. Oakley dokley? I'll take that as a yes. Slide 3, I'll do part B. What is the exact distance from the ship to the buoy? Now, I want you to, highlight the word exact there. Find the exact distance. What does that mean? Louis? Yeah, that's how we're going to work it out. Excellent. But I was even going one step before then and just attacking the question, which is find the exact distance. Even more simpler than that. Izzy's got it. Say it nice and loud for the class. Or no rounding. Yeah, we can write decimals and fractions as long as it's the full decimal comp. If it was 16.25, you could write that in if that was the entirety. But we can't round. So we don't do it to 3 significant figures, yes? Okay, so what Louis said was absolutely right though. We work out the magnitude. If we can work out the magnitude of the P vector, then we've worked out the exact distance. And we know the magnitude is simply the result of squaring each of the components, adding them together, and square rooting the results. We've got 15 squared plus 10 squared. That equals the square root of 325. And that is equal to 25 goes into 325 13 times. So it's equal to 5 root 13. Just for those who are a bit rusty on surds, this is just an aside. So if this bit on the blue here, you don't have to write into your notes, but if you're a bit rusty on it, just a reminder that the way we simplify or rationalize surds is we find a perfect square that goes into it. So in the case of the square root of 325, I can write that as the square root of 25 times the square root of 13, because 25 times 13 is 325. The square root of 25 is 5, and so we've got 5 times root 13, which is 5 root 13. That's how I did that, just in case you're a bit rusty on it. You should always rationalize surds if you can. And we will just conclude now, just to answer the question really. Therefore, the exact distance is 5 root 13, and I'll put the units in as well, kilometers. Okay, that's the exact distance. So if we had gone to our calculators and done root 325 and got a decimal answer, it would have gone on for a long time, the decimal part of it. And if you'd rounded to 3 significant figures, that would have not been exact. But leaving it in surd form is. That's about it for question 1. Does anyone have any questions before I let you at them? Okay, so over the page is questions 2, 3, and 4. I'm going to give you probably about 20, 25 minutes to get through them as best as you can. And then I'm going to come back and do question 4. I'll do that in a separate video, I think. If you get to the end of question 4, please feel free to start on the review exercises. I reckon that would be a good, solid foundation of reviewing our work on vectors. But note that in tomorrow's class, in Thursday and Friday's class, I'll bring past exam questions for you to have a go at as well. So I'll leave it there. I'll just stop the recording and then I'll take questions.